Hello friends, my name is Joseph Butera and I'm going to be showing you my new app that I just made in Google's AI Studio called NeuroLiquid. Now, NeuroLiquid is a spiking neural network simulator. It's creating a liquid neural network, which I feel is an understudied area of machine learning, and I just wanted to explore it in a way that I could understand as an artist and a musician. So let me just jump right into how to use the app. So in NeuroLiquid, what we're trying to do is have our little guy here, our little organism, survive inside of his environment and tinker with his brain, which is on this side in the liquid neural network view. Now, this isn't a neural network that we're used to in machine learning. This is using the biologically inspired spiking neural network model, where a neuron can fire based on its inputs, and it's always going to try to seek out new connections nearby because each neuron is like an agent. It's trying to stay alive inside of its world, so it reaches out, tries to make new connections, and that's how it stays healthy. It stays healthy by firing and being active, not by being inactive. So each of the neurons, including the sensors and the motor neurons that you see in this view, are all acting as their own agents, trying to make connections with each other. And from that, we can have behaviors that you're going to first see are very similar to bacteria and single-celled organisms that you see in a petri dish, but hopefully we can arrange something that's a lot more complex and a lot more interesting. So this is campaign mode. When you first launch the app, this is what you see first. And I'm just going to start the simulation, and then I'm going to explain how we can actually succeed in level 1. So I'm starting the simulation now, and not much is happening. We don't really see these neurons firing or anything like that. So what I'm going to do is turn up the background noise of the environment. So there's always noise inside of our environment, and that's going to cause our sensors to start firing randomly. And yep, now we can see those connections being formed. What I'm going to do is I'm actually going to move the motor neurons a little closer to the sensors so they start to form connections. And you can start seeing these lines that are forming based on the fact that they're firing. And right now, this is just using random noise. The sensors, which I'll turn on here, I can turn on the sensors by clicking this button. See, now the sensors are firing. Oh, and he was able to get a piece of food. So the goal of level 1 is to collect collect 5 food items. And our little guy's already doing that. He doesn't even have anything other than sensor and motor neurons yet, which is very much like the inside of a single-celled organism, right? It's just a membrane full of things floating around inside of it. And you know, the impulses that come in from the outside world directly affect what's going on inside, and they will directly affect how that organism behaves. And that's what we're seeing here. Great. We were able to collect 5 food items, and we can continue on to the next level. So from here, we've actually got some hidden neurons that we can play with. Now, having played with this a bunch myself, I do know that you can amplify the effect of a motor neuron by having other neurons that fire into it, right? If that makes sense, if you have neuropathy in your muscles become weaker because the nerves feeding those muscles are not as active in making that muscle move, and it becomes atrophied. So if we add more neurons near those motor neurons that can fire also from the influence of the sensors. So I'll kind of move those in here, move this one up here, and then maybe we'll keep one in the middle. I don't know. Like, this is why you have to tinker with it. And then we can press go. So what we're trying to do on this level is maintain a 70% average neural health. And that is visible right here. So we're up to 60% now. It's feeling pretty healthy. These neurons are green. That means they're healthy. That means they've made some good connections. They're firing. They're pretty happy. But we're not up to 70% yet. So, and there we go. We just hit 70%, and now we can go on to the next level. Now things are going to get really exciting. This is Hebbian learning. Hebbian learning is when neurons that wire together fire together, right? So remember, it's all about proximity. And when you're building this brain, you don't think of it in terms of like layers of a neural network or anything like that you might have learned before. It's really about proximity and these neurons having the ability to make connections between each other. Now, I can start with all of this just random. If I just move this slider, it'll replace these the hidden neurons in random locations. We're still keeping our motor and sensors in the same place. Let's just see what happens when it's random. So you can see the connections are starting to form kind of like a constellation. That's really interesting. And the energy sensor is starting to fire because we can see the energy is starting to drop. The energy sensor fires more and more. Oh, this looks like a feedback loop. That's kind of like having a seizure, right? If you have a feedback loop that's not feeding anything else, that's going to be using the energy. It's also raising the temperature of our organism. So this isn't really good to have these just firing and firing. They're super happy because they're firing, but all it's doing is getting a little bit of energy into this neuron here. Maybe it's not the best arrangement. It is still working though. The guy's still surviving, but uh-oh, he's entered starvation state and he's gonna die. Nope, he stayed alive. He just barely made it. Even though he's got this feedback circuit that's just using up his energy and raising his temperature, he's still kind of getting through. I don't think he's going to make it past this one. Oh, he's dead. He starved to death. It's a skill issue. So let's improve his skills. So I'm going to pause. I'm going to try to arrange these neurons in a different way. So let's see here. I'll move one kind of near these motor neurons here, one up here, down here, maybe one in the middle. So when I restart, okay, so sometimes making a geometric shape works. It looks a little bit like a heart. Isn't that cute? Okay, so let's go. Let's see what happens. So his learning rate's really high. One thing I can also do is I can make him forget a little bit more. So spike bonus, like how much is each neuron satisfied by getting a spark or a spike from another neuron. I'm going to make that satisfaction very low. I'm going to let the health decay faster, and that'll improve the plasticity. So we can also turn up the passive decay. That's going to clean up any dead connections that aren't sitting by, and I can also decrease the growth check so that the network learns more often. And you can see some of those connections are starting. Oh, and he's dead. But that's good. We want to start over with a more fresh network. Oh, look at him go. He's using up a lot of energy, though. That means I need to turn down the learning rate. There we go. He's still starving. It's going. Yep. Oh, he's dead. So I'm not going to tell you how to solve the game. What I've done is actually implemented a feature where you can actually save and load the different brain configurations that you've created. So if you click this button up here, you can save a JSON file. In the Kaggle competition, I've uploaded a couple that you guys can download and play around with. But I'm actually going to switch over to sandbox mode, which exposes all the different features and actually show you some of the brains that I've created and what makes them interesting. So if I upload this one's called Liquid Hair Net, because why not? I can restore the connections or not. I can get just the pattern of the neurons, or I can restore it with the connections that I've saved. So this is with the connections that I've saved, and it looks just like a blob. This kind of randomly grew out of running the simulation for 5 generations. And there is a evolutionary algorithm that's baked into this. There's a little bit of reinforcement learning happening so that in subsequent generations, it's trying to adjust these hyperparameters and the locations of the neurons to help evolve a brain over multiple generations. I'm not finished with that yet. I think there's a lot of room for improvement there, but this is a good start. Now watch the behavior of this guy. This guy is able to survive quite a long time. The network is quite active. You can kind of see it rippling back and forth. Look at him. He finds food and he goes and gets it. Yum. Look at him. He's just getting it. Just getting it. Even when his energy drops, this network has learned how to become more active. And look at him. You know, this behavior is a lot more deterministic than the simpler network. And would you have thought to design a neural network that looks like this? Probably not. It's just a blob, right? That's why I called it the liquid hairnet. I literally just had the sensor and motor neurons in a place. I slid the slider up and was just, I'm just testing. But for whatever reason, after 5 generations, you can see the number of generations here. When I reloaded it, this thing is very performant. I've had this guy exceed 10,000 ticks of lifetime. That will unlock some new sensor neurons, which are very super fun to play with, that I encourage everyone to try to achieve in this app. And yeah, this, sometimes just getting random with this kind of stuff is you can learn a lot, right? So let's try another one. Let's upload another guy here. This one's, I call the excited football. I'm going to restore the connections. Now this one is a geometric shape, and we can watch how it behaves. Okay, we'll start it up. So it's actually fairly active, but it's also burning up a lot of temperature, but I've adjusted those parameters. So for example, the stability and regulation parameters are very important. The target firing rate, there's tooltips down here at the bottom that you can read, but that's going to keep the firing rate inside of a certain range. And also the homeostatic strength, where it's trying to self-regulate and not exceed a certain rate and not try to exceed that target rate so that you don't go into that seizure state, right? I can demonstrate how the seizures work in here, but that's definitely something to avoid, right? That means your network is out of balance. Its structure is not this very careful balance of being able to survive in the environment and make good decisions versus it's being overactive. So this little guy is fairly performant. He doesn't live quite as long as the liquid hairnet, but it's a good example of how sometimes oh look, we had a forgetting happen here. Oh, but he's still starved. And if we look down here at the stats, he was able to get 13 food and lived 4,000 ticks, which is pretty good, right? So here, let me just show you one more, which I think is pretty interesting, which is just a big old blob. Okay, so this is a blob of just random stuff. And you can see, this is where I think things get really interesting. You see new network connections starting to form because these neurons out on the edge are starving. They need to make new connections. And now we're starting to see some interesting things light up. And it's it's kind of going around in circles, but by tweaking these hyperparameters, you can actually dial in something that looks very chaotic like this and actually get it to start working fairly well, which is fascinating. Now, what I think a good way to actually really dial in a fancy network is to pause it, go down to 0 hidden neurons, come up with an arrangement of the sensors and the motors that makes a lot of sense. It makes sense to have the left sensor near, or at least on the same side as the right motor neuron, and the right sensor on the same side as the left motor neuron. So in biology, organisms are symmetrical for a reason, because they are able to self-organize in ways that are predictable. If you don't have symmetry, it's hard to have a nervous system that is organized enough to give you an advantage in your environment. Otherwise, don't have a nervous system at all and just absorb from whatever's around you. Now, when the environment becomes more chaotic and harder to survive in, that's when you need to start having these more complex structures. And that's also why I buy into the idea of assembly theory, where you do have these fundamental building blocks to create complexity over time. And we can see that things like this is a simulation of a multicellular organism, but we can see the building blocks that had to go into this simulation. So yes, we have this multicellular organism, but you can imagine that each one of these neurons evolved from a single-celled organism, right? So each one has their own agency, and the behavior, the careful balance and curation of the organism as a whole creates that multicellular organism that can succeed in its environment better than the single-celled one. So all of them working together creates the whole. And then as that whole becomes more and more developed over time, those building blocks have become solidified into one new building block that can then go on to create more and more complexity. So this app is actually giving us a way to probe that thought process in machine intelligence and actually kind of have our own ways of intuiting this type of network, in seeing if we can deploy that in applications that we find interesting, right? So in robotics and things like that, we want to have continually learning systems that adapt constantly as the environment is changing around them. And that's what this kind of network can do. You can see there's no there's no training involved. It just starts working. And in order to survive, it's constantly adapting the network in order to stay alive. So that's the part that I'm super, super interested in. And we can actually explore using a toy example like this. Now, the next step is to perhaps render this in 3D, have a 3D liquid neural network, have image input on one side and actions on the other side, and really start to connect this in more and more sophisticated ways, because with this kind of network, you can build them in analog, in the analog domain using op amps and just simple transistors, and really reduce the workload as compared to doing matrix multiplications on GPUs, right? So let's get back into messing with this simulation right here. So there's no hidden neurons right now, and they're trying to form some connections. So I'm just going to randomly add a couple of them in order to start amplifying the activities that are there. So he's going to starve. That's fine. I'm not going to show that anymore. So by coming up with something where these sensors are going to fire, I want to amplify them a little bit, and then maybe move my motor neurons in a little bit closer, right? So you start to get an idea that, the structure really defines the function, right? The form follows the function, and having a form that makes sense is one of the ways that we can get to intelligence. It's not something that you can actually throw a math problem at, but you can throw this kind of concept into an environment and have it learn from it. You can see this neuron was starting to starve out here. It was turning red and created a new connection with this neuron, which is now firing from the energy sensor. So it's still not surviving yet. You still need to go in there and tweak things. Maybe adding more neurons is better, right? Maybe it's not. So we can see some interesting things happen. If we turn up the learning rate, well, that's cool, but that's a seizure, right? So that's going to be a problem. So this app kind of gives you some ways of understanding the dynamics of a liquid neural network, and understanding some ways that we could design some more fundamental components that could be used in robotics. For example, a flight system in a drone, they've explored using liquid neural networks for that, and they're extremely efficient and become very, very accurate in a very short amount of time. So something I'm super excited about. I hope you guys have fun playing around with NeuroLiquid. It was super fun to build. And if you guys have any questions, hit me up. Peace.